Okay, so this next part, we're going to write a system of equations and identify our variables. Again, we're not going to solve yet. We're going to do that next time. And these ones are all working with currents and speed of a vehicle, like boats or planes, and then also currents of the river and then air speeds for wind. With these problems, we're going to be typically setting them up in the same format. So with them, we are going to take the amount of time that a trip is going to take. Typically, it's in hours, and we are going to multiply that by the speed of a vehicle or whatever object is moving. And then we are going to add or subtract the speed of the current or wind. Depending on what type of problem it is. So when you take the amount of time spent times the speed that an object is moving, the result is going to end up being the distance that has been traveled. Distance. All right, so that's the outline of how we're going to set up our equations for these types of problems. So let's look at letter A. A boat can travel 16 miles up a river, and when you're going up a river, that means you're going against the current. So you want to kind of think about a lazy river. This would be like if you took your tube and you were walking the wrong way in a lazy river. So it's going to be very difficult to walk because the water's pushing against you. So up a river means we're subtracting the current of the river. The same boat can travel 36 miles downstream. So this is like you're sitting on your tube and you're just floating down the lazy river. The current is moving you, and if you were to walk, it would push you faster. So downstream in 3 hours. Find the speed of the boat in still water and the speed of the current. We still have to identify our variables. That question at the end is a hint of what your variables need to be. So X, I'm going to have be the speed of the boat. And Y, I will have be the speed of the current. All right. With the speed of the boat and the speed of the current identified, now we can write our equations. So the first sentence talks about a trip that was 2 hours. We're starting with our time, 2. And this one, the boat was traveling up the river, so against the current, meaning we are going to subtract. So we start with the speed of the boat, X, and then we're going to take away the speed of the current, Y. And then once we take time multiplied by the speed, that will give us the distance traveled. They told us they traveled 16 miles. And that is our equation. Our next equation, the same boat can travel 36 miles downstream in 3 hours. So we'll start with our time, 3 hours. Now we're going with the current or downstream. So we are going to take the speed of the boat and we're going to add the speed of the current because it's pushing us. So it's making us go faster. And you can see that because we also traveled a total of 36 miles. So that is what our equation would be equal to. I know we're not solving at this moment, but once we do get to solving, we don't want our equations to have these parentheses. So one thing you might want to practice is distributing this too, so that you don't have to worry about the variables and the setup later on. And you only distribute it to the parts that are inside the parentheses. So these are the same equations, but again, once we get to solving, we don't want those parentheses. All right. Our next example. So if you want to pause and try these last two on your own, you can, and then hit play to double check your answers. For example B, we have a motorboat makes a 24-mile upstream, so again, against the current, trip on the river against the current in 3 hours. The return trip with the current takes 2 hours. So with the current, we add the speed. Find the speed of the motorboat in still water and the current speed. So sorry, not A, I don't know where I got that from. X equals the boat speed. Y is going to be current speed. Again, you have to define your variables for full credit. So the first part was a 24-mile trip with 3 hours, and we were going upstream. So we would take the hours times X minus Y because we're taking away from our speed. So the speed needs to be smaller, equals our distance of 24. Then our second equation, we had a trip that was 2 hours, and it was the same trip that we took before. So we still are going 24 miles because we're just returning back to where we came from. So we're going to take that 2 hours, and then we're going to take the speed of the boat, and we're going with the current. So the current is pushing us along. So it's going to make us go faster. So we'll add that to our speed, and it still equals 24. So if you left it like this, we're just writing equations, this would be okay. Once we get to solving, though, it's going to make it easier if we don't have those parentheses. So we're just going to distribute the 3 and then also the 2. This will give us the equation 3x minus 3y equals 24, and the equation 2x plus 2y equals 24. And that would be our answer. All right, the last one, this one is working with airplanes. When an airplane flies into the wind, it can travel 3,000 miles in 6 hours. Into the wind means the wind is pushing against you. So that means it's going to be taking away from your speed. When it flies with the wind, so this means the wind is coming behind and it's pushing the plane forward. So it's going faster. It's going to add to our speed. It can travel the same distance, so same distance, in 5 hours. Find the speed of the plane in still air and the speed of the wind. Again, define your variables. You get points for this. It's very easy. Even if this is the only part you get, partial credit is better than 0. So always define your variables. I'm going to do speed of the plane and then speed of wind. Okay. So our first part said that we flew into the wind, so taking away that speed, went 3,000 miles in 6 hours. So we'll take the amount of time we traveled, the speed of the plane minus the speed of the wind because the wind was not helping us go faster. It was slowing us down. That will give us our total distance of 3,000. Then our next part, when it flies with the wind, so we're adding the wind speed, it can travel the same distance in 5 hours. So we take the amount of time, speed of the plane plus the speed of the wind, and we traveled the same distance. Okay. And again, if we want to practice getting ready for when we will start solving these, we want to make sure we distribute and get rid of those parentheses. So we're not changing the equation, we're just simplifying it a little bit. You would get 6x minus 6y equals 3,000. 5x plus 5y equals 3,000 as well. And for now, we're just practicing writing. We will get to solving next time.